Hi everyone, today we're going to go through the ME1 experiment, or conversion of mechanical energy to electrical energy. We're going to be looking at a little bit of the theory first, and we'll go through and have a look at the equipment and see how the experiment's done, and then we'll finish up by looking at some of the data analysis. So let's start by thinking about some of the theory. When we're converting mechanical energy into electrical energy, there's going to be some amount of loss. So what we want to look at today is how efficient we are converting that mechanical energy into electrical energy. We're going to be measuring the electrical energy using the Capstone software, which you might be familiar with, and we're going to be generating our mechanical energy mostly via gravity. The first stage in part A will be looking at basically a rotating object with some string, and then in part B we'll be looking at how we can actually convert falling water into electrical energy in the same way that a hydroelectric dam might. Alright, let's get started.
One place where we see mechanical energy converted to electrical energy and vice versa all the time is in electric motors. So you might have heard of electric cars. They actually use electric motors to deliver electrical energy into rotational energy to actually drive the wheels. And we're seeing this pop up all over the place. But how do we actually model that physically? So let's look at, for this experiment, modeling gravitational potential energy as our mechanical energy here. And we're going to convert that gravitational potential energy into kinetic energy, so kinetic movements, and in this case rotation, and we're going to see how much electricity that can actually generate. So we're not going to think too much about how the actual electrical energy is generated here. That's done using the electric motor. But let's have a look at how we can actually estimate the amount of energy that we're putting into the system. So if we know the mass of an object, we know gravity, and then we know the height change that that object has, we can calculate its gravitational potential energy, and we can work out how much of that energy actually gets converted into movement by using the kinetic energy formula, 1/2 mv squared. M again is the mass of the object, and v is the velocity that that object reaches as a result of that conversion from gravitational to kinetic energy. So we can use all of this to figure out what the input energy into our system is, and then we can use the Capstone software in the experiment to work out how much electrical energy we're generating and figure out what the efficiency is. We're going to use some fairly basic equipment for part A. So we're going to use some masses, which you can see pictured on the left. We're also just going to use some regular old sewing string to actually hold the masses and then rotate them around the wheel that you can see in that center image. So that wheel there is actually a little electric motor which we've connected up to the Capstone software. And as that wheel rotates, we can estimate the amount of electrical energy it's generating because there's actually a tiny little magnet in there that actually spins around a coil and generates electricity using the electric motor. So when we rotate that wheel, we can actually directly measure how much electrical energy we're generating. And the last thing we'll need to actually do the experiment here is to get an idea of what electrical generating capacity we've made over time. And we'll be doing that by recording using the Capstone software. Now, part A actually comes with its own spreadsheet so that you can work out the efficiency very easily without having to do all of the analysis that it would take. If you're interested, you can actually look into these equations in Excel and see what they represent. But for now, at least, you just have to worry about putting the data that you measure in your experiment into the spreadsheet. Part A of the experiment includes a spreadsheet where you can put in the data that you take in the experiment and then get out some values without having to do all those tricky calculations yourself. If you look here, you'll see that the orange areas are actually where you'll put your own experimental data, and then the green areas are where you'll record results onto your Performer or for your formal lab report, depending on what you're doing. So you can see we've got 3 different heights corresponding to the 3 different trials that we take, as well as the different masses that we look at. As well as that, you'll be putting in the times and the electrical energy that you're generating, which you'll measure both from the Capstone unit. Finally, you'll be recording the unaccounted for energy and the overall efficiency of the system from the 2 green areas in the spreadsheet. Record these on your Performer or jot them down for your formal lab report. Alright, so we're going to do a trial now, and this time we're going to be using 20 grams just to see what happens. Now you'll notice here that I'm actually putting the string around the larger wheel in the experiment itself, we want to use the smaller wheel just because it gives more reliable data and it'll actually speed the wheel up a little bit more and give us a little bit more electrical energy generated. All right, so let's have a look and see what the data looks like. All right, so let's do that experiment again now with 100 grams and see what the difference is in the energy that we generate. All right, so that's two example trials of what we look at in part A. And you can see there is a little bit of a difference between the masses that we put on there and the energy that we generate. Let's move on and learn a little bit about part B now. So the theory in part B is very similar to the theory that we looked at in part A, except the mass that we're moving this time is actually a volume of water, rather than just a mass on a bit of string. So in this case, what we're going to be doing is moving water around a tube, which will then go into a water wheel and spin the motor in the same way that we did it in part A. The cool thing about this is this actually models how a real hydroelectric dam might work. And so we use the gravitational difference, so the potential energy that we get by the height of that water, and effectively let it fall down into a turbine to actually create that mechanical energy in real electric dams. And so we're doing the same thing here with this experiment. And we can estimate exactly how much water that we're passing from one height to the other by working with equation 4. So the mass of the water is equivalent to pi r squared times the height that the water falls times the density of water. And what this does basically is it lets us know, well, what's the volume of water that we've passed through this area first? So we get that from the pi r squared h, which is just the volume of a cylinder. And then we multiply that by the density of water. And what we get from that is a volume of water with a specific density. If we multiply those together, we should get the mass of water that's passed through the area. And then we can use those same equations we looked at earlier where we can figure out what the gravitational potential energy of the water is and then see how much electrical energy we actually generated to see what the efficiency is. All right, let's go and have a look at the apparatus. So very similar to part A, we've got the exact same kind of electric motor here, except this time instead of putting the rotating wheel on it, we've got a water wheel that we've 3D printed. And basically you can see in that center picture there that the water will pass through the tubing into the nozzle, which will then aim it directly at our water wheel. And that water wheel will rotate as the water moves across it, obviously. And that will create the rotational mechanical energy that we want to use to create electrical energy. Just like with part A, we're going to be measuring the power, so that's the amount of energy per second that we measure from our water wheel over a period of time. And we're going to be looking and seeing how much electrical energy we calculate from that by finding the area under that curve. Now this will be done in Capstone. You don't have to do that maths yourself, but you will have to record the value under the curve using the Capstone software. So make sure that you note that down when you do your experiment. But if you're doing this online, that value will be given to you. On the left, you can actually see the water cylinder that we're using in this case. It's up on what we call a lab jack, just to give it that gravitational potential energy. And you can see that it will fall down through that nozzle and then come back out down through the nozzle straight onto the water wheel in part B. All right, let's go and have a look at the experiment. All right, so now we can see that the apparatus is here in front of us. We've got the wheel there as well as the water. Let's open the valve and let some water through and then see what actually happens on the graph as we let water down through. We should see that it should taper off over time as the water level gets lower and the value of mgh decreases. So we can see that the actual peak height has decreased like we would expect as MGH itself decreases. You might be wondering what some of those funny patterns are in the graph, and that's actually just a display limitation with the actual software. Because it's recording so many data points so quickly, it's having a lot of trouble plotting them properly, and so they come out with these funny patterns. So don't read too much into that. We just want to look at the overall area that's actually being measured, which gives us the total energy being transferred into our electrical motor. So now that we've got the area measured, which actually gives us the energy that's been created through our motor, we can work out what the efficiency of our system is based on those calculations we made earlier. But we'll leave that to you to do. And for now, we'll go on and we'll finish this video up.
Thanks for following through on this video on the ME1 prac, the conversion of mechanical energy to electrical energy. I wish you all the best for your prac. If you're having trouble, please ask your demonstrator for help. Good luck!